Hey guys, so are we ready to learn about some new fun things, symmetry and dilations? Oh my gosh, I'm excited for you. It's going to be a good time. So we're going to start with just symmetry. Oh, but before we begin, yay math! Yay math! Great job. Okay, so for symmetry, you should already know kind of what that word means, but we're adding a different type of symmetry in a second. So there are two types. The first one is what you're most familiar with, reflectional symmetry. That's like, when you were in elementary school and they were like, this butterfly has reflectional symmetry, or they would probably just call it symmetry. So now we're calling it reflectional symmetry because there's another type. And all it means is that if you can draw a line somewhere through that figure, that it's going to be the exact same figure on the left side of the line as the right side, or it doesn't have to be left or right, this could be rotated like that, but on one side of the line it's exactly the same as the other side, right? Okay, so like if you had a perfect smiley face, okay, that's not perfect, but you get the idea. If it were perfect, this would have a line of symmetry right down the middle there, ish. Okay, yeah. So that would be, okay. That would be reflectional. It's also called line symmetry, and that's because you can draw a line of symmetry through the figure for it to be reflectional, right? It's like a mirrored image. So what I'm going to ask you is, given a figure, how many lines of symmetry does it have? So we're going to look at some examples. Now to do these ones, you're probably going to, you can just sketch a picture, but it would be helpful probably if you had the geometry templates. So just get a template and I'll show you which ones you need to trace. Okay, you want to pause right here to go get one, pause. Actually, you should have some on your desk, but okay. So draw a square. And then we're going to determine how many lines of symmetry the square has. Beep, boop, beep, boop. Okay, you're done? Good. So we have this line here, right, that goes straight down through the middle. So imagine folding along that line. It's going to match up exactly. That's a line of symmetry. This is a line of symmetry. Is that it? No, we have a line of symmetry here, and then a line of symmetry here. And that's it. So you count how many we just did. That's 4 lines of symmetry. Okay, 4 lines. So you and your partner, I want you to work on, no, my examples are at the bottom. So let's do rotational first, and then I'll let you do some practice. Okay, so the next type of symmetry is called rotational symmetry. This one's a little different and probably new, but it's a figure that rotates to be exactly the same shape. What does that mean? Well, take an equilateral triangle. If I were to take this equilateral triangle, and let's see if I can do this. Okay, I colored it in with blue. If I were to take that equilateral triangle and rotate it like this, it should match up exactly. Now mine should be exact, but it's not because I didn't use a stencil, right? So whenever you're doing these, you might want to use stencils. So that should match up exactly, okay? And then can I do it again? Oh, yes, I can. Whoa, this is crazy. It matches up exactly. And we're back to the original happy smiley triangle. So the reason is because it's equilateral, it's perfect, it's all like the same on all different sides. Basically what we're doing is we're rotating it this many degrees so it looks exactly the same. And you can check with patty paper always. And you'll notice that we did in this example, it had 3 rotations until it got back to the original shape, until a full 360 degrees. So if I want to figure out what is what's called the angle of rotation, you're going to do that 360 and divide by the number of rotations. So go ahead and type that in your calculator. What do you get? 120 degrees. So 120 degrees is my angle of rotation. Okay? All right, if you're still confused on rotational symmetry, we'll do some of these examples together. Okay? So first draw an equilateral hexagon, so a regular hexagon. And then number 2, you're going to want to draw a parallelogram. That's, I think, number 33 on the stencils. Okay. And then you have a right triangle. It's also, these are all on the stencil template thing. Okay. And look at the question. Determine if each shape has line or rotational symmetry, or both, or neither. So let's talk about line symmetry first. Remember that another word for that is reflectional symmetry. So we want to figure out, does it have any lines of reflection? So we can see most of you are probably going to do this line of reflection, line of symmetry there, line of symmetry there, line of symmetry here, right? Should go through, there we go. Well, that's not exact, okay. Again, I didn't quite use the stencil here, so we're not exact. Should use a stencil. Okay, but is that it? No, because look at this. That's a line of symmetry. And so is this. So is this. Right? So count those up and you have 6 lines of symmetry. So it definitely has reflectional. Now, does it have rotational? Okay, so I'm going to erase my lines. I'll come back to that. But here's where you might want to use your patty paper. So if you need to go get some patty paper, go get some patty paper. Okay, but I'm going to, if I had my patty paper, I would trace this hexagon on the trace paper. And then I would take that paper and I would physically rotate it. So if I rotate this, hold on. I like to draw smiley faces so I know what my original shape is. Okay. So if I rotate this around the center like that, that's going to match up. So that's 1 rotation. 2, 3, oh, sorry, 4, 5, 6. Okay, so